Hello and welcome to Ganesh Institute channel. So today we are going to discuss about another test to check whether the series, infinite series basically, convergent or not, or divergent you can say. So in this series we are going to discuss, in this range of tests we are going to discuss about D'Alembert's ratio. So the question is in front of you that check the convergence of this series. So similarly, as we are going as we have been doing the test, you need to find out firstly the general term. So if you see here, x square, x cube, and then up to so on up to x raised to power n, right? And then in denominator you can see this is 1, 3, 5, 7, 9, that means odd terms, and here 2, 4, 6, that means even. So in odd 2n minus 1, and for even 2n. You can choose 2n plus 1. I mean, we have this thing as well in odd series, but we need to check which one will fit in the term, in the series. If you put, see, this is your first term, so if you put n as 1, so x, and in denominator 1, 2 times 1 is 2, 2 minus 1 is 1, 2 times 2 is 2, so 1, 2, so that is, it is satisfying the thing. So this is un. Now remember this bit, when it comes to D'Alembert's ratio test, there are three things which you need to take care of when you are doing this question. So if you want to check whether this particular series is convergent or not, so there are three things. Firstly, for convergent, you need to find out the value of un plus 1, and then un is, we always find out the value of un. You need to find out the ratio of un plus 1 and un. You need to find out the limit n tends to infinity for that. If this part is having value less than 1, then it would be convergent. If this part, limit n tends to infinity un plus 1 by un, has value more than 1, then it would be divergent. And if it is exactly 1, then you cannot apply this test, because this test fails when it comes to value exactly this ratio as 1 over the limit n tends to infinity. Okay, so let's find out. We have got un. Now we need to find out what? Un plus 1, right? So if you see, for un plus 1, let me write down this x raised to power n, 2n minus 1, 2n here. So this is your un. Now for un plus 1, what it would be? X raised to power, in place of n you need to put n plus 1. X n plus 1 divide by 2. N is n plus 1 now, minus 1, and 2, n is n plus 1 now. So 2n plus 2 times 1 is 2, minus 1, and then 2n plus 2. That means 2n plus 1 and 2n plus 2, right? So substitute this value here, 2n plus 1, 2n plus 2. Now you have got un plus 1 as well as un. Now you need to find out this value, which is limit n tends to infinity un plus 1 by un, which is x raised to power n plus 1 by 2n plus 1, 2n plus 2. This is your un plus 1. And divide by un. Un is this, x raised to power n, 2n minus 1 into 2n. Now if you see, if you take this in reversal form, so it would be x raised to power n plus 1, 2n plus 1, 2n plus 2. Then this will come up and this goes down, right? So if you see, same base in division, power got subtracted, powers get subtracted, so n plus 1 minus n is only x. Now you have 2n minus 1, 2n, 2n plus 1, 2n plus 2, right? But over the limit n tends to infinity, right? So solve it. Whenever you have n tends to infinity, you need to take common. Take common n from here and n from this term. So n square will be common. and you have here 2 minus, you can write 1 by n, and this is 2, right? Then again from here take n as common, so 2 plus 1 by n, and you can take n as common, so 2 plus 2 by n, right? So have you got this thing why I wrote here 1 by n? Because if you see, this is 2n minus 1, and if you want to take n as common, it doesn't have n, so multiply and divide it with n. If you take n as common, 2 minus 1 by n, so this is how it gets this form. Now limit n tends to infinity, so you have taken n from here and n from here, so this will become n square. N square got cancelled with n square. And now if you substitute n as infinity, so this goes 0, this is 0, this is 0. What is left? Above, this is 2x by, this is 0, you have 2 here. When you multiply this with 2, so this is 4. And in denominator as well, it is 4. 4 is cancelled with 4, you have x, right? So that means you have value of un plus 1 by un, this value, n tends to infinity, limit, this is x. So according to D'Alembert's, we need, because question is asking for whether this is convergent or not, so we need to check what? We need to check whether the value is greater than 1 or less than 1, right? So, or equals to 1. So clearly it is, if x is greater than 1, if x is greater than 1, then because the value is itself x, so this value, if this value is greater than 1, the series will be divergent. That means un will be divergent. If x is less than 1, then the series will be convergent. But what about x is equals to 1? If we know that if this limit turns out to be 1, then this test fails. So then you need to apply some other test. Let's say comparison test. Okay, you need to find out which test you are going to apply and whether it fits or not in the series. Just like for Cauchy integral, you need to make sure that your series is decreasing, monotonous decreasing. And here we can apply comparison test. So as you know, for comparison test we need to find out firstly un, general term, which is our, where is un? Here, x raised to power n by 2n minus 1 2n, right? X raised to power n 2n minus 1 2n. Now if you see 2n in multiplication, okay, if you see this is having value as what? And x is, we are checking this at x is equals to 1, so we are not taking s raised to power n, instead 1 raised to power n, which is 1, 2n minus 1 2n, right? Now you need to find out or assume another function vn or series vn. Now what it would be? You can check out my comparison test video where I have already explained this. So if you see n and n, this is having highest degree of n as 2, n square, right? Which is 2. It would be somewhat in the form of this. So you need to take this form for vn. So this value is what? 1 by n square. Now you need to find out whether vn is convergent or divergent in order to check whether un is convergent or divergent. Okay, so if you are having, and in that sense you need to find out vn by un. Okay, you can write it as limit n tends to infinity vn by un. So vn is your 1 by n square, un is your 1 by 2n minus 1 2n. So this goes up 2n minus 1 2n by n square, and limit is tending to 0 to infinity, right? So similarly, when this is the thing, you can take n as common, n from this thing, n from this, so n square, 2 minus 1 by n, and here only 2, n has been taken as common, and in denominator n square. Limit tends to infinity, so this goes 0, when 1 by infinity is 0, so what you got? 4. Because it is greater than 0, it is positive and infinite, that means Vn series is convergent, right? And if Vn, general summation of general term, it is convergent, then Un will also be convergent according to comparison test, right? So that means at x is equals to 1, see, for greater than 1 it is divergent, for x less than 1 it is convergent, and for x is equals to 1 according to comparison test it is convergent. So you can compile it over like, for x greater than 1 it is divergent, and for less than 1 or equals to 1 it is convergent. I'm hoping that you got this thing clearly, and if so, then don't forget to like, share and subscribe my channel. Till my next video, take care of yourself. Bye bye.